as I've said before in Algebra 2, everything, absolutely everything, depends on you understanding functions. And that's the reason we start with functions on day one. If you don't understand functions, you will struggle mightily through the entire year. So as we look down at our picture here, we know right away that this is a quadratic. That should have popped into your head as soon as you saw the shape. This is a quadratic. And as soon as you thought about that, you knew what the parent function is, which is x squared. Now those three things tied together should be in your head at all times. If it's a quadratic, it looks like a parabola, it has an x squared. All of those. You have to know all the functions, you have to understand what is inside their equations, you have to understand their vocabulary. Now, if it's a parent function, which this one appears to be, then it passes through 0, 0, or that's its vertex in this situation. So that is critical to understand. So now we're going to slide this over. We're going to move it over, and we're going to find a new equation, and that's how we usually represent it, a G or an H or a J. This is the new equation, and we're going to decide we're not going to change the old equation, and we already know what the old equation is. It's a quadratic. Now I'm not going to write the equation. What I'm going to write is some relationships. This is the function notation for this movement. Now function notation just tells you how it's going to move. It doesn't even tell you what it is. If you looked at this, you would have no idea what the function is if the picture weren't sitting there. But what this function notation tells us is this little +2 that just tacks onto the end of any function makes it go up 2. Anytime you add something on the end of a function that's not part of the function, you're going to shift, you're going to slide, you're going to translate the function up. If that were a -2, what do you think we would do? You would translate it down. All right, now let's look right here. If this end part is up and down, well then obviously this is left and right. So this is 3 right. Now right there you said, now Miss Fields, it can't be right, it's got to be left. It's got to be going to -3. Well, when we are outside the function, it's normal, it's logical, it's a +2, therefore you go up 2. But when you are inside the function, it feels very backwards. It feels like it's opposite. And it is opposite, and later on we're going to figure out exactly why. But for right now, I need you to just think about it. It's opposite. So if my head kept telling me, well, it's got to go left 3, then we are going to go right 3. So let's map our movement. We're going to go right 3. We're going to go up 2. And that's our new vertex, and we're going to draw our parabola. Because nothing else changed. It didn't tell you to make it bigger or smaller or flip it over. All it told you to do was move it. And it told you specifically how to move it. Move it 2 up. Move it 3 right. Alright, let's try another one of those. So, let's get rid of this. And let's get rid of this. And let's try another one. Okay. What if it told me to make a new function using the old function and this time put +2 minus 4? Okay. What do you think it makes us do? Well, we said that anything tacked onto the end, just shoved onto the end, that makes it go up or down, and it's very logical. So this would be 4 down. Now, inside the function is left and right. And since it's left or right, we're going to think, oh yeah, it must be right. But it's not. It's 2 to the left. Why is it 2 to the left? Because it's opposite. Because it's backwards. We're going to figure out why, but let's for right now think it's going to be backwards. So that's 2 to the left. Well, what does that look like? Okay, so I'm going to go 2 to the left. I'm going to go 4 down, 1, 2, 3, 4, and that is my new vertex, so I'm just going to draw my parabola. Right, you're thinking, well, this is not hard. It's not. And here's the beauty of it. Every single parent function does the same thing. All right, what jumped into your head? As soon as you saw this one, something should have jumped into your head. Absolute value, you should have known that. And the function is absolute value of x, and you should have known that. As soon as it jumped into your head, it should have been there. All right, so let's make a new function. Let's do this, g of x. All right, this time I want it to go plus 3 minus 2. Well, that looks like the same last one. Yes, because it's not telling you what the function is. You have a picture that's telling you what the function is. This is telling you how to move. Function notation tells you how to move. What changes? Function notation says, I got this picture, and now this is what I'm going to do it. I'm going to move it 2 down. I'm going to move it 3. Is everybody ready? Left. Very good. I'm going to move it 3 left because inside of the function is backwards. It's opposite. And 2 down. Okay, so let's start mapping. I'm going to go 3 to the left. 1, 2, 3. Why did I start right here? Because 0, 0 is the vertex of the parent function. So I'll move 3 to the left. I'm going to go 2 down. And then what am I going to do? Well, I'm just going to draw the same thing I had because all this is telling me is how to move. All right. Something should have jumped into your head right then. Radical, square root, and f of x equals square root of x. All of that should have jumped into your head the moment you saw it. All right. I'm going to make you do radical and square root because some of the things that are coming to you could use either word. So I want to make sure that you understand that's what it is. All right, let's make a new function. Let's make a new function out of the old function. So I'm not even going to tell you what it is. I'm just going to say this is the new function. And this is how you're going to move. I want you to move the old function plus 3 plus 4. Is everybody ready? Plus 3 plus 4. Okay. I think I want to do plus 3. This little screen is a little small. Okay. Now, what is this? Anytime you have something tacked on, added on to the end of a function, that makes it go up or down, and this is going to be up 3. Anytime you have something inside the function, that's going to be left or right. And what do we have to remember? Opposite. It's the opposite. Alright? So that's 3 to the left. Alright? So let's start moving. Alright, we're going to 3 to the left. We're going to go 3 up. Oh, gee, what am I going to draw? Oh, yeah, the same thing I've been drawing. Because I didn't change the function. I moved it. This is translating the function. Alright, what popped into your head? Things like cubic, things like f of x equals x cubed. All of that should have just jumped right in there. Alright, this one's a little harder to visualize, I think, for some kids. Alright, so I'm going to move it. I'm going to make a new function. And my new function is going to take the old function. I don't need an x cubed. I have a picture. I know what it is. I'm going to move it. X plus 3 plus 2. Oh, no, I'm not. I'm going to change this. And I'm going to move it to x minus 3. Let's try that one. Alright. Now, anytime we tack on something on the end, plus 2, that's just up 2. That's normal. It makes sense. What are we going to do right here? We're going to move 3. We're going to go left or right, but which way are we going to go? I think we're going to go 3 to the right, because what are we supposed to remember? Opposite. Everything's opposite inside the function. Alright, so let's try this. We're going to go 3 to the right, 1, 2, 3. We're going to go 2 up, 1, 2. And that is our transition point on this one. Instead of a vertex, it's more like a transition point. So I need to go up and I need to go down. And there's my cubic. So basically, what did we find? We found that this right here makes it go up or down. And we realized that this makes it go left or right. But the biggest problem you're going to have all year long is that, what does that negative mean right there? It means opposite. We have to remember, this is up or down and it feels normal. This is left or right, but it's going to feel opposite. So let's do a couple just to say. Okay, so if I'm making a new function, what is it going to do? 9 up and 3, and what's the key here? Well, my brain's telling me plus 3, that must mean right 3, but it's opposite, so it's left 3. Alright, take a stab. I need you to try to get through all the very basic ones that I gave you on your handout so that we can get all the way to the really good stuff.